Here we have a pre-calculus problem. Okay, let's go to the question. Solve log base 8 of x positive log base 4 of x positive log base 2 of x equals to 11. Solve means we have to find the value of the variable x in this equation. Okay, for that, what we can do is that we can consider the stuff we have on the left side of the equation. Here we have addition of 3 logarithms. But here, the base of the first logarithm is 8, the base of the second one is 4, and the base over here is 2. All the 3 logarithms have different bases. In case if all the 3 logarithms have the same base, we can use the product rule of logarithm. But here we cannot use the product rule of logarithm. So what do we have to do for that? For that, let me assume there is 1 multiplied in front of this logarithm and this logarithm and this logarithm. Okay, here 1 and this logarithm is multiplied. Even if I take the multiplication of 1 over here, still it is equal to log base 8 of x. Okay, now I'm going to move this logarithm to denominator. When I move this logarithm to denominator, I have to switch the base and argument. That is here in numerator we'll have this 1 divided by log, and now when I switch the base and argument, then I'm getting log base x of 8. So the same thing I have to do in the rest of the 2 logarithms. Then I'm getting 1 over log base x of 4 positive 1 over log base x of 2 equals to 11. Okay, here 1 over log base x. This 8 is a power of 2, so it can be written as 2 to the third power positive 1 over log base x. This 4 is a power of 2, it can be written as 2 square positive 1 over log base x. This 2 is a prime number, it cannot be written as a power, so we can keep this 2 as it is, equals to 11. Okay, now let's consider the power rule of logarithm, that is log base a m to the nth power. The argument of the logarithm over here is a power. Whenever the argument of a logarithm is a power, the exponent we have over here in the argument can be moved in front of the logarithm and it will be multiplied by the logarithm. Then the result of this logarithm equals to n times log base a of m. So that is we have moved this exponent in front of the logarithm. So we can use this power rule over here in each of these 2 logarithms. Okay, here the argument is a power, that is 2 to the third power. We can move this exponent 3 in front of the logarithm. Then we get 3 times log base x of 2 positive. Here we can move this exponent 2 in front of the logarithm. Then we get 1 over 2 times log base x of 2 positive 1 over we can write this one as it is, that is log base x of 2 equals to 11. Okay, if I want to add these 2 fractions, I need to have the same denominator for all the 3 fractions. Almost I have the same denominator, that is a log base x of 2. So each denominator contains list of log base x of 2. But here we have 3 multiplied, here we have 2 multiplied, and here we have to assume there is 1 multiplied over here. Okay, now to get the same denominator for all the 3 fractions we have over here on the left side, I have to find the least common multiple of these 3 and 2, and also it's 1, 3, 2 and 1. So what's the least common multiple for these 3 numbers? That is 6. So that is we have to make this number 3 as 6, this number 2 as 6, and number 1 over here as 6. Okay, to make this number 3 as 6, I have to multiply both numerator and denominator of the first fraction we have over here by 2, and here I have to multiply by 3, and here I have to multiply by 6. Okay, let me do it. So when I do so, I am getting 2 over 6 log base x of 2, the first fraction. The second one, 3 times 1 is 3, and in denominator 3 times 2 is 6, that is 6 log base x of 2 positive 6 times 1 is 6 divided by 6 log base x of 2 equals to 11. Okay, now I got the same denominator for all the 3 fractions. So now we can take this 6 times log base x of 2 as a common denominator. Then we get 6 times log base x of 2. And since I have taken this one as a common denominator, we have to add the numerators. It is 2 positive 3 positive 6 equals to 11. Okay, when I add 2, 3 and 6, I'm getting 11 over 6 times log base x of 2 equals to 11. Okay, now I can move this log base x of 2 to numerator. So when I move this logarithm to numerator, I have to switch the base and argument like what I have done over here when I move this log base 8 of x to denominator. So whenever we move a logarithm from numerator to denominator or denominator to numerator, we have to switch the base and argument. Then we get 11 times log base 2 of x. I switch the base and argument. In denominator we have 6 equals to 11. Okay, now to get rid of this fraction 11 over 6, I multiply both sides of this equation by the reciprocal of this fraction, that is 6 over 11. Let me do the same thing on the right side as well. So here 6 will cancel out, and 11 will cancel out. Okay, here this 11 and 11 will cancel out. Then I'm getting log base 2 of x on the left side. On the right side we have just 6. Okay, our aim is to get the value of x. So for that, we have to convert this logarithmic equation to exponential equation. How do we have to convert this logarithmic equation to exponential equation? For that, we have to consider the part which contains logarithm. So here we have logarithm on the left side. In this one, we have to consider the logarithm along with the base 2. Now, it has to be moved to the right side of the equation. So when I move it to the right side of the equation, we have to ignore this logarithm. We have to consider only the base of the logarithm on the right side. The value which already exists on the right side over here will become exponent of this base. So already we have 6. This 6 will become the exponent of this base. And now we have x on the left side. That is x equals to 2 to the 6th power. Okay, we know that the value of 2 to the 6th power is 64. Okay, in the given equation I have solved for x. The value of x is 64.